welcome to Algebra 2 with Mr. Clausen. Today we are going to start a two-part series on how to solve three-variable systems of equations. And today what I'm going to do is go over how to solve a three-variable system using elimination and how to solve a three-variable system using substitution. We're going to hit both in this video because we've talked about elimination and substitution before. So what I want to do is actually go over how to solve a system with three variables instead of two variables. So without further ado, let's get started here. Now, what I want to point out with any type of algebraic equation is that whenever you're trying to solve a system, if there's two variables, you have to have two equations to solve it. If there's three variables, you have to have three equations to solve it. You know, and that pattern continues as you get higher and higher. If you have 100 variables, you'd have to have 100 equations to solve it, right? And sometimes they have systems like that. If you use matrix algebra, that's how you handle a lot of these larger types of systems, which are typically applied to many computer programming examples and such. But in terms of this course, we're going to cap out at three variables because then things start getting a little bit more complicated and doing them by hand is a lot more difficult. But one of the things that I want to take into consideration here is I have a system of three variable equations, and what I'm going to do is I'm going to use the elimination method in order to solve it. Now typically when I'm solving these, I like to number my equations and then use that numbering system to dictate kind of what I'm doing and keeping track of everything that way, because these examples tend to become a little lengthy, and if you do not have a methodical way of kind of sorting through, even someone like myself that's been teaching this course for a number of years can easily get lost. So someone that probably hasn't solved a three variable system before, you're going to want a method in place. I'm going to try to model that to the best of my ability. But with this given example, I'm going to use the elimination method to solve it. And the first thing I'm going to pick up on right off the bat is I see that equation 1 and equation 3, if I add them together using the elimination method, I can cancel out x and then solve for y and z as a result. All right, it allows me to isolate those two variables while removing the variable x. So I'm going to start with that. I'm going to plug in 1, I'm going to plug in 3, because they don't require any manipulation, and I can just plug them in as is. So x plus y plus 2z is equal to 3, and negative x minus 2y plus z is equal to 10. And what's going to be really nice about this circumstance is these guys go and they cancel. All right, and then I get negative y plus 3z is equal to 13. Now, what's a little trickier about three variable systems is you're kind of going and navigating this tough situation where now you take two three variable equations and whittle it down into a new two variable equation. And this two variable equation here I'm going to keep track of, and I'm going to give it a number designation. I'm going to identify this as equation 4, all right, because I'm going to need to use that, but I need another two variable equation to plug into this. So with that said, I have to go and figure out where to find the second equation. Well, that second equation really needs to involve equation 2 from here in some way, because if I don't and I just use 1 and 3 again, things kind of cancel out and it gets real weird. So I have to take equation 2 here and I need to combine it with something else in some way. So like if I have equation 2 here and I say 2x plus y plus 3z equals 7, I have to use this in some way. It'd be kind of like asking equation 1 and equation 3 for their opinion and then not asking equation 2 what they thought of the situation. And you want to know what they think of the situation, because if you want to find a solution that works for all three, then you have to use them. But what I can do is if I want to figure out another two variable equation to create, what I can do is eliminate x again, but then choose to use equation 1 or 3. I think what I'm going to do is I'm going to take equation 1 but multiply it by negative 2. And you could choose to use equation 3 here as well, but I'm just going to do 1, because if I take 1 and I multiply it by negative 2, I'll get negative 2x minus 2y minus 4z equal to negative 6. So I took equation 1 here, and I multiplied all three components by negative 2. Okay, and so what this is going to allow me to do, again, it's kind of a long process, but what it's going to allow me to do is go eliminate the x and then solve by isolating the y and the z variable here. Okay, and now I created another two variable equation, and I'm going to identify this equation as equation 5. Okay, so just to recap, I used the elimination method using equations 1 and 3 to go and find negative y plus 3z equals 13. This created a two variable equation from two independent three variable equations. And then in order to get the third equation represented here, I took equation 2 and I used elimination in conjunction with equation 1 multiplied by negative 2 to get equation 5. Alright, so every time that you use the elimination method, it's going to look like this. You're going to need to take two of the equations to find an equation, and then incorporate the third equation with any of the other equations to get a second two variable equation. Now, what I'm going to do here is I'm going to go, and the goal is to isolate what one of the variables is, all right? And to do that, I'm going to take these two variable equations and I'm going to combine them here, all right? And I think I'm going to eliminate y so that I can solve for z. And so to do that, I'm going to take equation 4, I'm going to plug it in as is, and then I'm going to multiply equation 5 by negative 1 here. So what that'll give me is negative y plus 3z equals 13. And then I'll have y plus z equals negative 1. Use elimination again, get 12 is equal to 4z. And if we did this right, the y should cancel so that there's nothing left. I divide both sides by 4, and then z should equal 3. And what this allows me to do is, again, I used equation 1, equation 3, and equation 2. All three of these equations are represented in order to create equations 4 and 5. I started by eliminating x, and then I eliminated y in order to find z. So when you're going through this process, you have to be very intentional with each step that you're going through here, that you're eliminating one variable consistently until it's completely eliminated, all right? And then eliminate the second variable until you get to this z equals 3. Now, once you get to z equals 3, then everything becomes so much easier. Once you find one variable that's going to be consistent with equations 1, 2, and 3, then I can start working backwards, and I can start saying, all right, let's plug z into equations 4 and 5. All right, so if we plug z equals 3 into equation 4, let's say, let's just test this out and see what this looks like. This would give me negative y plus 3 times 3 is equal to 13. All right, subtract 9 from both sides. That's going to give me a negative y equals 4. So y is going to equal negative 4 in this given circumstance. All right, and again, we could check this very easily in the next situation and say that negative y minus 3 equals 1. Okay, add 3 to both sides. Very quickly find that negative y is equal to 4, and again, y is equal to negative 4. And so we can very easily see that y is equal to 4 in this case. Now to find the third variable, the first one that you eliminated, variable x, you can find this out very easily by checking your system. All right, and most problems I'm going to ask you to do is I'm going to ask you to check your ordered triple in all three equations. So to figure out what x is, what I'm going to do here is I'm going to check my solution. Delete that a little bit. I'm going to go check my solutions. All right, and so I have to leave x here super briefly. I'll put -4 in for y, plus 2 times 3 in for z is equal to 3. And what I'm going to find is that x minus 4 plus 6 equals 3. Do a little math here. X plus 2 equals 3. And so x is equal to 1. So my ordered triple is 1, comma, -4, comma, 3. That's my solution. But if the question asks you to check it, then we're going to check it in equations 2 and 3. So I just checked it in 1. It says 1 works. It should, because we just plugged it in there and we used it to find the x. That's okay to do. All right, and now I'm going to go 2 times 1 plus -4 plus 3 times 3. And we're going to check and see if that equals 7. So this will give us 2 plus -4 plus 9. All right, 9 minus 4 is 5 plus 2 is 7. Last time I checked, that's all good. So that solution works out. Let's plug it into 3. So -1 minus 2 times -4 plus 3 equals 10. All right, -1 plus 8, because two negatives make a positive, plus 3. All right, 11 minus 1 is equal to 10. So all three of those solutions work. All right, and so with that, you can clearly see that 1, 4, -4, 3 is the ordered triple for this given solution. And I apologize if you can hear a little squeaking in the back. It's our pet chinchilla letting me know that it is very deep into the night as I'm making this video. Now that I've shown you how to create a solution from a 3-variable system using elimination, now that I've shown you how to solve for a 3-variable system using elimination, I want to go over another example of how to solve a 3-variable system of equations using substitution. Now, in this given case, I'm going to do the same thing that I did before. I'm going to label 1, I'm going to label 2, and I'm going to label 3. And I'm going to create some equations, and I'm going to do some things to kind of go and solve for them. And you're going to want to pick and choose when you are trying to use each system. You might actually find elimination to be the nice go-to method, but there are definitely some circumstances where substitution is really nice, especially if you have a situation where one of the variables is already eliminated for you. Now, I'm going to do it this way. This is a harder example that can be solved using elimination, but substitution works out all right. And what I'm going to do is I'm actually going to substitute equation 1, and I'm going to plug that into equation 2 and 3. Again, we got to get the opinion of all three equations here. But in order to do that, I have to set the equation equal to some specific variable. So I'm going to take equation 1 here, and I'm going to subtract 3y from both sides and add z to both sides. And what that's going to allow me to do is create an x equals -3y plus z minus 4 situation. I'm still going to label this as equation 1 because it's just a rearranged version of equation 1. But what that's going to allow me to do is I'm going to take equation 1 and I'm going to plug it in to equation 2. All right, I'm going to substitute this in for x into equation 2. So what that'll allow me to do is it'll allow me to say 2 times -3y plus z minus 4 minus y plus 2z. All right, that'll all be equal to 13. And if I go and distribute the 2 accordingly, this will give me negative 6y plus 2z minus 8 minus y plus 2z equals 13. All right, and then that should come out as negative 7y plus 4z, and I'm going to add the 8 to both sides here, and this is going to equal 21. And what I just did by substituting equation 1 that's solved for x into equation 2, it eliminated x, so to speak, and it created a 2-variable equation from 2 3-variable equations. Again, that's the goal, is you're trying to whittle out these variables one by one. And with this, I'm going to set this as equation 4. Now, we're not done, and that's good, because like I said, we need 3 equations to solve a 3-variable system, and now we're trying to whittle those 3 equations into 2 equations with 2 variables, and then that can get us to one solution like we've done many times in the past. So now I got the opinion of 2 involved here from equation 1. So I'm going to take equation 1 and I'm going to substitute it into equation 3, because we want to get equation 3's opinion, because then that'll give us another 2-variable equation. So now we'll go 3 times negative 3y plus z minus 4. And then over here we have negative 2y minus z equals negative 9. And we're going to work through this one together as well. So negative 9y plus 3z minus 12 minus 2y minus z equals negative 9. So negative 9y, negative 2y, that gives me negative 11y. All right. And then what I should also have here, plus 2z, let's add 12 to both sides, equal to 3. And so with this, we should be sitting in a pretty good spot here in terms of we have a now new 5th equation, that's this 2-variable system here, and we can figure out how to solve for x or y pretty easily here. And so now what I'm going to do is I use substitution to create these 2 methods, and I can do it again and cycle in and set x or y or z equal to something for 4 and 5. But you know what? I'm looking at this. 4 and 5 are going to go together really well using elimination instead of substitution. So I'm going to apply that here and say that if I take 4 and then I plug negative 2 times equation 5 in, this is going to work so much better than trying to divide all this stuff out and make it into this really sloppy mess. So I'm going to go negative 7y plus 4z equals 21, and I'm very intentionally picking this because if I take negative 2 times 5, that'll give me 22y. It'll give me negative 4z, and negative 2 times 3 is going to equal negative 6. All right, and I'm doing this with the sole purpose of eliminating y. It just fell out as this really easy thing to eliminate, so I'm going to eliminate the y value here. So now I subtract 7 from 22. This will give me 15y. All right, 21 minus 6. This will equal 15. And I can find very quickly that y is equal to 1. I have one of my solutions. And so now what I'm going to do is I'm going to plug y into both of these equations and figure out what z should be. So if I plug in, y for 1 into this equation, into equation 4, I'll have negative 7 times 1 plus 4z equals 21. Negative 7 plus 4z is equal to 21. So add 7 to both sides. Very clearly see that 4z is equal to 28. It's a common score in football if you get 4 touchdowns. So I see that z is equal to 7. And I'm going to go and look at y equals 1. We'll plug that into this situation as well. we'll go to negative 11 times 1 plus 2z is equal to 3. Alright, and then we'll get negative 11 plus 2z equal to 3. Add 11 to both sides. 2z is equal to 14. Get another common score in football. Get 2 touchdowns. Z is equal to 7. Again. Alright, and so we're just checking these to see if these solutions match out. This is feeling really strong since I'm having this level of consistency occur. So now that we know what y and z are, let's go and let's substitute them into the end here to check the solutions. Alright, the first check is just to find what x is, and then we're going to see if that relationship holds true for 2 and 3. So let's plug in x. Let's go plus 3 times 1 minus 7 equals negative 4. We do a little math. We go x plus 3 minus 7 equals negative 4. So we'll have x minus 4 equals negative 4. Add 4 to both sides. Oh, so x is equal to 0 in this given case. So based on this information, I would see that my ordered triple would be 0, 1, 7. All right, this is our ordered triple. And so now let's just check the other two solutions. If I ask you to check all the solutions, you're going to get a score based on plugging this into all 3 equations. So we plugged it into 1 to find that x is equal to 0. So let's plug it into 2 and 3 as well. So we'll go 2 times 0 minus 1 plus 2 times 7 is equal to 13. So we'll have negative 1 plus 14 equals 13. This would be more than enough to say that that's good. And then let's do the same thing here. 3 times 0 minus 2 times 1 minus 7 is equal to negative 9. So 3 times 0 is 0. Minus 2 minus 7 is equal to negative 9. So that all checks out. And so with this, we can very easily see that this is our ordered triple. And always plug this back into your original equations. Don't sub it back into your substitution or anything like that, because maybe you did this rearrangement of equation 1 wrong, and that would be your error. If you're taking an exam, and also another thing I want to point out is if you get to this point and you check it and you're like, my ordered triple doesn't work out, unless you have a fair amount of time left, don't erase everything that you did. I will still look at your work. I will check your process, right? As you can see, there are a lot of steps, so it's very easy for one little thing to be misplaced, all right? And you get an issue when you go back and you check your solution. So it's really hard to make sure that everything is checked and working, and you get the right solution unless you go and check it in the end. So with that said, that's all I have for you. I hope that this video gave you a thorough understanding of how to approach 3 variable systems and how to solve them either using substitution or elimination. So with that said, let's do some math.